In this lesson, we're going to be talking about angles and parallel lines and how they interact with each other. But first, I wanted to talk about some basic definitions that are covered in Chapter 2. We're not doing Chapter 2 right now. We're probably going to come back to it later on in the year. The basic definitions I'm talking about are what is a postulate and what is a theorem, and how are they different. Both of them are statements, but a postulate is a statement that is true without proof. In other words, it's one of those basic ideas in geometry that is universally accepted as being true without having to have a proof done on it in order to prove that it's true. A theorem, on the other hand, is a statement that needs to be proven to be true. All the theorems that we're talking about, though, have already been proven to be true, but we're going to, at some point this year, going to be doing some basic proofs of some of the theorems that we're going to talk about. Back to the postulates that we've already talked about, postulate 2.1 says through any 2 points there's exactly one line, and postulate 2.2 through any 3 non-collinear points or 3 points that are not on a straight line, there's exactly one plane. Those are 2 postulates that we've already worked with that without actually having it being specified that those are postulates. Postulate 2.3 and 2.4 are basically the inverse of the 2.1 and 2.2. Postulate 2.3 says that a line contains at least 2 points, and 2.4 says a plane contains at least 3 non-collinear points. 2.5 is one that we haven't really talked about, but it says if 2 points lie on a plane, then the entire line that containing those 2 points lie on that same plane. Right? That's pretty much common sense. Postulate 2.6, we've talked about or worked with just that if 2 lines intersect, then their intersection is exactly 1 point. And if 2 planes intersect, then their intersection is a line. We talked about that type of thing just in the last lesson when we were identifying intersecting and parallel planes and lines. All right, so the first theorem that we're actually going to look at is the vertical angles theorem. This is also going back to previous lessons, but because we're going to be using vertical angles in this lesson, I wanted to have you guys write down the vertical angles theorem. The vertical angles theorem says that if 2 angles are vertical angles, then they're congruent. There's a postulate also that we're going to be talking about that actually is dealing with this lesson, is the corresponding angles postulate. Remember the last lesson we talked about the parallel lines and their transversals and how the angles correspond with the transversal and with the lines and how they interact with each other. Remember, corresponding angles are angles that occupy the same relative space in a intersection between a transversal and parallel lines. In other words, here's the transversal. So remember, this is the top left. This is top right. This is top right, and so on. Bottom right, and bottom left. Okay, so those are corresponding angles. 1 and 3 are corresponding. 2 and 4 are corresponding. 5 and 7 are corresponding. And 6 and 8 are corresponding. So pause the video and copy this into your notes. All right, so a couple examples to just go over these basic points. The measure of angle 3 is 75 degrees. Angle 3 is this angle right up here. It's 75 degrees. What's the measure of angle 8? Well, angle 8 is right here. Okay, so we want to find what that is. If you look at how they interact with each other, these two angles are formed by two lines that cross. So that means these two are vertical angles. Okay. So, and we talked about just a minute ago that vertical angles are congruent. Okay, so that means angle 8 is also 75 degrees because congruent angles have the same measure. If the measure of angle 10 is 105 degrees. Okay, what is the measure of angle 2? All right, measure of angle 2 is also 105 degrees because angle 10 and angle 2 are corresponding angles. Okay. Measure of angle 6 is 75 degrees. What's the measure of angle 1? Well, you can see here that those two angles are formed by the intersection of line W and line Y. And so these are vertical angles, and vertical angles are congruent. So angle 1 is 75 degrees. If the measure of angle 16 is 75 degrees, what is the measure of angle 14? Well, we can see here the transversal here is X. We can ignore these angles up here because they don't have anything to do with this one down here. And you can see 16 and 14 are corresponding because they are both bottom right angles. Okay, corresponding angles are congruent, so that means angle 14 is also 75 degrees. All right, so some more theorems that you guys are going to need to copy down. I'm going to talk about 3.1 and 3.3 first because they're related. Okay, the 3.1 alternate interior angles. Remember, alternate interior angles are angles that are between the two parallel sides. They're on the interior between the two parallel lines, and they're on opposite sides of the transversal. So alternate interior angles are congruent. Along the same lines, alternate exterior, they're on the outside of the parallel lines, but they're on opposite sides of the transversal. So that makes them alternate, and alternate exterior angles are also congruent, which means they have the same measure. 3.2, theorem 3.2, consecutive interior angles. Remember, interior are the angles that are between the two parallel lines, and consecutive means that they're on the same side of the transversal. So in this case, angle 1 and 2 are consecutive interior angles, and angles 4 and 3 are consecutive interior angles. And consecutive interior angles are supplementary, which means that they equal 180 degrees. All right? So whenever you have two consecutive interior angles, their sum has to equal 180 degrees. So pause this video and copy these theorems into your notes. One more theorem that we're going to talk about in this lesson is the perpendicular transversal theorem, and it's basically all it says is that if you have two parallel lines that's cut by a transversal that is perpendicular to one of the lines, then it is also going to be perpendicular to the other parallel line. And so that's pretty straightforward. So just quickly copy that into your notes as well. All right, so we're going to do some examples dealing with this. Okay, measure of angle 16, right here. 16 is 75 degrees. What's the measure of angle 9? Okay, so one of the things, because I've got several lines here, I've got four lines here, I'm going to identify which transversal we're talking about. Okay, so we're talking about transversal X, so we don't have to worry about line W at all. You also notice that we've got these little arrows here on lines Y and Z, and all those little arrows that are in the middle of the line or in from the end of the line, all that means is that those are parallel lines. That's what signifies that they're parallel lines. All right, so 16 and 9, those are both exterior, and they're on opposite sides of the transversal. So these are alternate exterior angles. Alternate exterior angles are congruent. Okay, so that means that angle 9 is going to be 75 degrees. Right? If the measure of angle 9 is 75 degrees, which we just found out that it was, what is the measure of angle 5? Well, angle 5 is this one up here. Now, so the transversal that we're talking about here is line Y, so we can totally ignore all this mess up here dealing with that. Now, if we look at angles 5 and 9, we see here that they are between the two parallel lines. So that means that they are interior. Okay? They're interior angles. Okay? And they're both on the same side as the transversal, so they're consecutive interior angles, which we said that consecutive interior angles add up to 180 degrees. So we can say angle 5 plus angle 9 is equal to 180 degrees. We know that angle 9 is 75 degrees, so we know that angle 5 plus 75 is equal to 180. And then just to solve for angle 5, we subtract 75 from both sides. We end up that angle 5 is equal to 105 degrees. All right? So 105 is equal to 105 degrees, and that sort of makes sense because you can see angle 9 is an acute angle and angle 5 is an obtuse angle, so that would make sense. All right, if the measure of angle 7 is 105 degrees, angle 7 is 105 degrees, what's the measure of angle 12? Well, look, 7 and 12 are both, 12 and 7 are both interior, okay? Those are both in because they're between the two parallel lines. All right. So they're both interior angles, and they're on opposite sides of the transversal, which this is the transversal Z here, so we can ignore all these down here. So they're on opposite sides. That means they're alternate interior. Alternate interior angles are congruent, and so that means that angle 12 is also 105 degrees. All right, so sometimes we're not given the actual measure of the angle in degrees. Sometimes the angle measure is expressed as a an expression, and this is the case here. And we still use the same scenario and the same method for finding it. Once again, this one has the two arrowheads in from the end. That means these two lines are parallel. They want us to find the value of x. So we have a 7x. We have an 8x minus 10. Okay. So we're just going to set those equal to each other because these are interior. They're alternate interior because they're on opposite sides of the transversal. Okay. So they're interior and they're alternate because this is on the left side of the transversal here. This is on the right side. So we have 8x minus 10 is equal to 7x. I'm going to split the thing. I'm going to move the 7x over to the left-hand side. So minus 7x minus 7x. We have to be careful here because the 7x minus 7x gives me 0. Here I have 1x minus 10 left over. Then I'm going to add 10 to move it over to the right-hand side. 0 plus 10 is 10. So we have 1x, or just plain old x, is equal to 10. Okay, so that answers the question for the value of x. So some of the questions you may run into or might ask you, what's the measure of the angle? Well, if it asks you to find out what the measure of the angle is, all you do is you take that value of x and you plug it in. So 7 times x is 70. Okay, 8 times x is 80 minus 10, which would be 70 as well, which we would expect that to be the case because they are alternate interior angles. Now, using the information that we learned here, the next question wants us to find the value of y. All right, well, so using that information, we know that this up here is 70 degrees. We know this down here is 70 degrees. Okay, and so we could use these two measurements here because we know this is a linear pair that adds up to 180 degrees. But because of the lesson is parallel lines and how they interact, we're going to use this. These are interior angles and they're on the same side. So these are consecutive interior, okay? Consecutive interior angles that are supplementary, or they add up to 180 degrees. So we can say 6y plus 20 plus the 70 degrees that we found out from the last example. We know all that's going to equal up to 180 degrees. So when we do that, we're going to collect the like terms. 20 plus 70, we end up with 6y plus 90 is equal to 180 degrees. Then we solve for y. Minus 90 minus 90. We end up with 6y is equal to 90. Divide both sides by 6. And we find out that y is equal to 15. All right. So we know that the value of y is equal to 15. If it asks us to find the measure of the angle, there's a couple different ways of doing that. We could take this 15 and plug it into here, and we could say 6 times 15 is 60, or is 90, plus another 20 is 110. Okay, we can find out it's 110 that way, or we could say, well, I know that they have to add up to 180. This is 70, so 180 minus 70 is equal to 110. And you can see that is in fact the case. All right, one last example. It says to find the value of x. Well, we have corresponding angles here. These are both top left when we're talking about how they interact in the intersection here, top left and top left, which means that they're congruent to each other. So we say 11x minus 1 is equal to 9x plus 21. Solve for x by subtracting 9x from both sides. 9x is canceled out. We're left with 2x minus 1 is equal to 21. Add 1 to both sides. The 1's cancel out on the left. We end up with 2x is equal to 22. Divide both sides by 2. X is equal to 11. All right. So our value of x is equal to 11. We can plug it in. We can plug that value in here. 9 times 11 plus 21. When we do the math there, 99 plus 21 is equal to 120 degrees if we're actually asked to find the measure of the angle itself. If we could also have done it on the bottom here. 11 times 11 minus 1. 11 times 11 is 121 minus 1 is 120. All right, so that does it for this video. Go ahead and take a look at your classwork. Make sure that you've copied down all the notes. I'm going to be asking to see them if you have watched this video before I'm at your facility. So make sure you copy the notes. Make sure you ask questions if you have any. We'll see y'all later.